In this question, we want to solve the exponential equation 15 to the 4x plus 3 equals 11 to the x plus 2. Before we get started on this question, I have some information on some methods for solving exponential equations. Let's take a look at those. So we have three main methods for solving exponential equations. The first one is called relating the bases, or sometimes it's called the one-to-one property for exponential functions. This method deals with the situation when you have a base to a power on the left and that same base to a power on the right of your equation. And when you have that situation, this relating the bases or one-to-one property says that the exponents must be equal to each other. So it allows you to simplify the equation from an exponential equation to some other type of equation. So I wrote out some details in words. This requires the exponential equation to have the bases on both sides be the same. And when the bases are the same, the exponents must be equal. And because of that one-to-one property is the reason why the exponents must be equal to each other. So this is one method for solving exponential equations. Another method is to convert the exponential equation into a logarithmic equation. So you would start off with some exponential equation. You rewrite that using the definition of logs. You notice that the base of the exponent is the base of the log. The log always equals the exponent. So we have our exponent of x is what our log equals. And then whatever the exponential expression equals is what goes inside of our log. So some comments are that this requires your exponential equation to be isolated on one side of the equation. You convert to a logarithm using the definition of a logarithm, and then you solve the remaining equation by isolating x. So then we have this final method, which I call take the log of both sides. You start off with an exponential equation. You take the log of both sides using the logarithmic property, the logarithmic one-to-one property. Then you're allowed to use the power rule for exponents, and that allows you to take this power and make it the coefficient on the log. And then you're going to solve for x by isolating x, dividing both sides by natural log of b. So some thoughts on this method. It requires the exponential to be isolated on one side of the equation. You're going to take the natural log of both sides. This is allowed by the one-to-one property of logarithms. You're going to use the power rule for logarithms to multiply the exponent. And then you solve this should say remaining, not renaming, equation by isolating x. So these are the three methods, the three main methods of solving exponential equations. And I'd really like to use the first one, which is relating the bases. However, I have a base of 15 and a base of 11, and I cannot make those bases the same. So that means the first method is out, and I can either convert to a logarithmic equation or I can take the log of both sides. Generally, I prefer this third method of taking the log of both sides, so I'll use that approach on this example. So I am taking the log of both sides, and I use natural log of the left, natural log of the right. When you do this, you're allowed to now use the power rule for logarithms that allows you to take this power and turn it into the coefficient on the log. And you can use the power rule on this side to become the coefficient on the log. So that would give us 4x plus 3 natural log of 15 equals x plus 2 natural log of 11. Now I'm going to use the distributive property. I'm going to distribute this natural log of 15 to each term in the parenthesis, and I'll distribute the natural log of 11 to each term inside this parenthesis. That's going to give me 4x natural log of 15 plus 3 natural log 15 equals x natural log of 11 plus 2 natural log of 11. Now I want to group the terms that have x to one side of the equation. So this term has x, and this term has x. So to group them together, I'm going to move this x to the other side. And we have some terms that don't have x. And we want to group those terms without x on one side. So I'm going to go to the other side with the terms that don't have x. So to regroup, this 4x natural log of 15 is staying on the left. I'm going to move that term x natural log of 11 to the other side. So to move it to the other side, we need to do the opposite operation. We have minus x natural log of 11. On the other side of the equation, the 2 natural log of 11 is staying on that side, but we're going to move the term 3 natural log of 15. We'll use the opposite sign to move it. That's minus natural log of 15. Now that we've grouped all the x terms together, I'm able to factor out a common x. Factor out the x would leave me with 4 natural log of 15 minus natural log of 11. I'm copying down the other side, 2 natural log of 11 minus 3 natural log of 15. And I can solve for x by getting x by itself. X is multiplied by what's in the parentheses. I'll solve for x by doing the opposite operation, which is division. So I'll divide by 4 natural log of 15 minus natural log of 11. I'll do the same thing to the other side to keep my equation balanced. On the left-hand side, the 4 natural log of 15 minus natural log of 11 cancels, leaving me with x. And on the right-hand side, I'm left with 2 natural log of 11 minus 3 natural log of 15 divided by 4 natural log of 15 minus natural log of 11. So this is my final answer. This is the exact answer. Sometimes you might be asked to give an approximation, and so you can use your calculator to get that approximation. So let me pull up my calculator. Got my calculator opened up, and I want to type this expression in my calculator. I want to put parentheses around the numerator. We've got parentheses 2 natural log of 11 minus 3 natural log of 15. I need to close parentheses for the log and also close parentheses for the numerator. Then I'll divide. I also need parentheses around the whole denominator. So parentheses 4 natural log 15 minus natural log of 11. I'm going to close parentheses for the log and close parentheses for the whole denominator. And I just want to be sure that I close parentheses for the first log that I typed. Okay, looks like I closed that parenthesis. So now I see that this expression is equal to negative 0.39. And let's say we round to 3 decimal places. Make sure to follow the instructions on your question. So we've got negative 0.395. And this would be the solution to our exponential equation. For this question, we want to solve the exponential equation. And our equation is 1.41 to the x equals square root of 2 to the 1 minus 3x. Now we just discussed some different methods for solving exponential equations. One of them involved relating the bases, making the bases the same. And although these bases are very similar to each other, if you were to type in your calculator square root of 2, you would get approximately 1.41. And because it is approximately and not exactly equal, we cannot use that relating the bases. The relating the bases requires you to have exactly the same base, not approximately the same base. So I'm going to use the method of taking the log of both sides to solve this exponential equation. I'll take the natural log on the left. I'll do the same thing to stay balanced on the right. Now that I've introduced the logs, I'm allowed to use the power rule for logarithms, which takes this power and makes it the coefficient on the log. And I'll do the same thing on the right-hand side. Using the power rule, it allows you to make the coefficient, make the power the coefficient on the log. That would give me x natural log of 1.41 equals 1 minus 3x natural log square root 2. On the right-hand side, I'm going to use the distributive property and distribute this natural log square root of 2 to both terms inside the parentheses. This gives me x natural log of 1.41 equals natural log square root 2 minus 3x natural log square root 2. Now that I've gotten rid of the parentheses, I want to collect the terms with x to one side of the equation. I have an x in this term and I have an x in this term. I want to group them to the same side. I'm going to move to the left-hand side. I have one term that doesn't have x. I'm going to leave it on the right, and once I move that other term with x, it will be isolated on one side of the equation. So reorganizing these terms, I will have x natural log of 1.41, and I'm going to move that minus 3x natural log square root of 2 by doing the opposite sign to move that to the other side. And that leaves natural log square root 2 isolated on one side of the equation. Now that I've grouped all of the x terms to the same side, I can factor out the x, leaving me with natural log of 1.41 plus 3 natural log square root 2 equals natural log square root 2. Now I can isolate x by dividing by the parenthesis. Parenthesis is multiplied, so we're dividing to do the opposite operation. And we're going to do the same thing on the other side to keep our equation balanced. That's natural log of 1.41 plus 3 natural log square root 2. These parentheses cancel on the left, leaving me with x, and on the right I'll copy down what I have, and this will be the solution. Natural log square root 2 divided by natural log of 1.41 plus 3 natural log square root 2. We may need to give an approximation, so let's use our calculator to get that approximation. So in the numerator, natural log square root 2 is the only term, so I don't need parentheses around the numerator. I have natural log square root 2. However, in the denominator, I have more than one term, so I need to put parentheses around the denominator. It's natural log of 1.1, that should be a 4.1, plus 3 natural log square root 2. I don't need that parenthesis there. Let me get rid of that. But I do need the parenthesis on the log, and I do need to close the parenthesis for the whole denominator. And this gives us the approximation of 0.25, and let's round that to 3 decimal places, 0.251. So we have the solution to our exponential equation being 0.251. Thank you for checking out my videos. Have a great day.